In this video, we will identify the characteristics and distinguish between branch circuits, feeders, and taps. So let's just start right into the definitions. First of all, a branch circuit. As defined by the code, a branch circuit is the circuit conductors between the final overcurrent protection device and the equipment.
And here's what it looks like from NEC 100. The definition of branch circuit. Here we have some circuit conductors. They are between the last overcurrent protection device and the outlet or outlets.
Now let's move on to feeders. First of all, it's kind of easier with a feeder definition to really recognize what a feeder is not. We have a picture here of a service. Feeders are not service conductors. Service conductors have their own definition by code, so let's get that image of those kind of conductors out of our head when we're thinking about feeders. Also, as we just defined, feeders are not branch circuits. So if you have conductors that are beyond the final overcurrent protection device, it's not a feeder.
And here's what it looks like from NEC 100, the definition of a feeder. All circuit conductors between the service equipment, the source of a separately derived system or other power supply source, and the final branch circuit overcurrent device. And here's another look at feeders and branch circuits, including a shameless plug for some of our industry partners. Starting from the left and moving to the right, we have a Siemens service, and then a Siemens panel, followed by an Eaton disconnect and some lighting from Brex. And then about 2/3 of the way over, we've got an Eaton transformer, followed by another Siemens panel and a Leviton outlet. Now let's put some conductors and conduit in place here. In between the service and the first panel, we have some conductors. We've got conductors going out of that to some utilization equipment. We have some more conductors and conduit, thanks to Atcor International, heading to our Eaton disconnect. Then from the disconnect to the transformer to another panel, and finally to another load. So let's look at the different types of conductors we have here. We have some branch circuit conductors. We have service conductors. And now let's identify these feeder conductors. They're all the conductors between the service and the last overcurrent protection devices. So we have some here, and here, here, and there. Now, these conductors that we pointed to that are next to this transformer actually take on another definition. They are transformer secondary conductors, and they have additional rules that apply to them.
The next definition we're going to look at is tap conductor. So if we head to Article 100 in the code, we will be disappointed. Tap conductors are defined in Article 240.
A conductor, other than a service conductor, that has overcurrent protection ahead of its point of supply that exceeds the value permitted for similar conductors that are protected as described elsewhere in 240. A tap conductor is a bit of a rule breaker, and as such is going to have a bunch of other little rules to keep it safe. Here are a couple things to note from the definition. It's not a service conductor, and it has overcurrent ahead of it that just seems too large. This is going to help cue us in when we're in the field. Here we have an example of a tap. In this photo, you can see up in the wireway, up in the gutter, there's a kind of a terminal block with large conductors coming in the left and then feeding out to these smaller conductors coming out on the right-hand side to this disconnect. You can't see it very well, but let's zoom in a little bit and look more closely. On the left side of this terminal block, you can see that those conductors are quite a bit larger than the ones coming out of the right-hand side, and the overcurrent protection device, which we can't see, for this set of conductors is sufficient to protect those large wires. Or rather, the ampacity of those wires is not less than the overcurrent protection ahead of it. But on the right-hand side, these smaller conductors are not protected like they generally would be in Article 240. Here's another example of a tap, and mostly I wanted you to see the kind of connector that is used here, just because this is something that you might see quite frequently. Right here we can see large conductors coming into this 200 amp Eaton breaker. Then you can see, there's our breaker. Now you can see listed connectors tied onto those large conductors, and shooting off of those are some smaller conductors. We actually can't see the overcurrent protection that is protecting those first conductors that I mentioned. But this is the kind of situation that if we could see it, it would definitely reflect that the overcurrent protection is matches the matches the feeder ampacity, and these tap conductors would not be protected by that feeder overcurrent protection device. So we mentioned that taps are rule breakers. So let's find the rules in the code. It would be good for you to follow along in your code as we do this. Article 240, Part 2, location. It starts with 240.21. There are three common kinds of taps. Feeder taps, including transformer primary conductor taps, are found in 240.21b. Transformer secondary conductors are found in 240.21c, and motor circuit taps found in 240.21f, which will direct you into the motor code of 430.28 and 430.52. There are a few other kinds of conductors that look and feel like taps that the code addresses in Article 240. We've got branch circuit taps, service conductors, busway taps, and generator and battery conductors. We are going to focus in this video on feeder taps and their rules. Now, before we get into all the little rules, we are going to remember 240.21. Should be pretty easy to understand and remember. You can't tap a tap.
So let's get into the details of feeder tap rules. They're found in 240.21b, which has 5 subsections. And each of these subsections has subsections that spell out all the rules for each kind of tap. Taps that are under 10 feet, taps that are 10 to 25 feet, transformer taps, taps that are outside, and taps that are greater than 25 feet. So now would be a really good time for you to get out your code book and start following along. 240.21b1 is for taps that are not longer than 10 feet long. Sometimes this is called the 10-foot tap rule. Just to make sense of some of these codes, remember that taps have to abide by all of the following. Tap conductors aren't allowed to burn up. That's what one of the subsections says. You can't put more load on this conductor than it's going to be protected from. Taps have to be physically protected. And for this rule, for taps that are 10 feet long and less, the tap ampacity has to be at least 1/10 of the size of the feeder overcurrent protection device. Here we have an example of a tap termination. On the left, you can see larger wires coming in, and out to the right, you can see those smaller wires. We're going to call those our taps, and the wires to the left are going to be our feeders. Let's say that those feeders have an overcurrent protection device that is 300 amps. And these tap conductors are 8 feet long. They would have to have an ampacity of not less than 300 divided by 10, or 30 amps. Next, 240.21b2. This is for taps that are over 10 feet and less than 25 feet. Again, it has a rule that you have to follow all of the criteria listed in that section. Taps must terminate in a load-limiting overcurrent protection device. So after you string your taps out, you have to terminate in some kind of protection that's going to limit the load to that conductor. The rule for this length of tap is that the ampacity has to be not less than 1/3 of the feeder overcurrent protection device. So going back to this same example, but now these tap conductors coming off of the right-hand side of that terminal lug, they are 22 feet long. Our feeder overcurrent protection device is still 300 amps, but now the ampacity of those tap conductors cannot be less than 300 divided by 3, or 100 amps. So 240.21b3. This is for taps supplying a transformer, where the primary conductors and the secondary conductors combined are not greater than 25 feet. We have to remember a little bit of transformer theory when we think about this rule, because the primary conductors, if the voltage is high, they are going to be carrying less current than the secondary conductors if the secondary voltage is low. So those conductors have to be sized appropriately for the current that they're going to carry. And that makes these rules a little bit funky. We'll see what I mean. Taps supplying the primary must be at least 1/3 of the feeder overcurrent protection device size. Okay, so similar to these rules that we've been talking about already. Secondary conductors have to be at least 1/3 of the feeder overcurrent protection device times the primary to secondary voltage ratio. And all this does is protect these secondary conductors, as they are going to be carrying more current than the primary conductors. Conductors have to be physically protected. We've seen that subsection before. And the secondary conductors also must terminate in a load-limiting overcurrent protection device. Transformer secondary conductors have a whole set of their own rules that are very much like feeder tap rules. In fact, you'll find them in 240.21c. And this 240.21b3 is kind of a cousin to those. So we're not going to talk about it too much in this lesson, but we will address those rules more when we talk about transformers. On to 240.21b4. This is taps that are over 25 feet long. This is kind of an obscure section because it only applies to feeder taps supplied from a feeder that is in a high bay manufacturing building with walls that are over 35 feet. So if you ever come across the scenario, here are the rules, but it is kind of an obscure section. There are 9 rules, more than the other feeder tap rules, and we're just going to talk about the one rule that applies to size. The other rules are about supervision and protection and length, but this one we're just going to talk about the sizing rule. And it's easy. It's the tap ampacity has to be no less than 1/3 of the feeder overcurrent protection device. And now, finally, 240.21b5, outside taps of unlimited length. These have to be physically protected, like our other taps. They have to terminate in a load-limiting overcurrent protection device. But other than that, there isn't a sizing rule associated with these taps. So there you have it. Branch circuits, feeders, and taps. Branch circuits and feeders don't usually give us too much grief, but those tap conductors with all of their different rules sometimes do. So let's get into some examples.
Now I have 2 practice problems for you to work through. I'll show you the problem on the screen and you can pause the video before and allow yourself time to solve the problem before moving on to the solution.